Hello everyone. So in last class, I think in last class someone was asking me about the presentation slides. So if you go to the chat section of this meeting, so you can find the OneDrive link that I have uploaded all my slides there. So um, after 1 or 2 days of the interaction sessions, you will be getting the slides of the respective interaction sessions. So I think it will help you. Thank you. So we'll wait for a few minutes more and we should wait for others to join, then we will start. So in the meantime, while we are waiting for others to join, do anyone have any doubts regarding the previous interaction session that we discussed few questions regarding the measurement tools like vernier caliper, screw gauge, etc. Hello everyone, we'll be starting the session in a few minutes. So if anyone has any question or doubt regarding the previous interaction session, they are welcome to ask me. Any doubts regarding the previous session? My voice is clear to all of you. Can you hear me properly? Hello, am I audible to you? So you can all see my screen. Hello, can you see my screen? Anyone?
No, sir. Cannot screen.
Now can you see?
No, sir.
Okay, sir.
Okay, you can see now then. I think it is visible now. Yes. Hello, can you see it?
Yes, sir.
Okay, so hello everyone. Good evening to all. I welcome you again for the interaction session on Experimental Physics 1, which is being flowed by NPTEL in this July 2023 session. This is the second interaction session today. I am Vivekananda Naik, a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So So in the last session, we discussed about a few measuring tools like vernier caliper, screw gauge, and other different concepts regarding significant digit, doubtful digit, etc. So now we will, in today also, we will be continuing our discussions. So let's start with our first question of the day. The question says, consider a vernier caliper in which each 1 centimeter on the main scale is divided into 8 equal divisions and a screw gauge with 100 divisions on its circular scale. In the vernier calipers, 5 divisions of the vernier scale coincide with 4 divisions on the main scale. And in case of the screw gauge, one complete rotation of the circular scale moves it by 2 divisions on the linear scale. Then there are four options given. We need to identify which of these options are true. So the first option says if the pitch of the screw gauge is twice the least count of the vernier calipers, then the least count of the screw gauge is 0.01 mm. And second option says the least count of the vernier gauge is 0.005 mm. So from these two, I request everyone to mute themselves. So and in the so only one of the two options is true, and in the second two options it is given if the least count of the linear scale of the screw gauge is twice the least count of the vernier calipers, the least count of the screw gauge is 0.01 mm. So there are two different conditions. So one is the pitch of the screw gauge and another is the least count of the linear scale, because as you can see in the question, we have informations regarding the vernier calipers, like it has 1 centimeter is divided into 8 equal divisions, and in case of in case of vernier caliper, the 5 divisions is equal to 4 divisions in the main scale. But regarding the screw gauge, we don't have much information. So related to the vernier caliper, we need to calculate the least count and pitch of the screw gauge. So I'll be giving you a few minutes to try this, then we'll be discussing this question in details. So please try the question and tell me which of these four options are true. I think you can see the screen clearly, isn't it? Can you see the questions clearly?
Yes, sir.
Okay, so try the questions. I will be giving you a few minutes, then we will discuss this question. So let's solve this question. So the question says, consider a vernier caliper in which each 1 centimeter on the main scale is divided into 8 equal divisions, and a screw gauge with 100 divisions in its circular scale. And in case of the vernier caliper, 5 divisions of the vernier scale coincide with 4 divisions of the main scale. And in screw gauge, one complete rotation of the screw gauge moves by 2 divisions in the linear scale. So as you can see here, we have more information related to the vernier caliper. So we'll be starting our solution from vernier caliper. So can anyone tell me what is the formula for calculating the least count of the vernier caliper? Because in any case we have to first calculate the least count of the vernier caliper. So can anyone tell me what is the formula for calculating least count of the vernier caliper?
Main scale division minus vernier scale division.
Yes, right. So first we'll calculate vernier caliper's least count. So for vernier caliper, the least count is given as 1 main scale division minus 1 vernier scale division. So if you calculate the 1 main scale division, so in the question it is mentioned, in case of vernier caliper, each 1 centimeter is divided into 8 equal divisions. So the 1 main scale division will be how much? 1 by 8 centimeter. So it will be 1.25 mm. And in case of the vernier scale division, it is given 5 divisions of the vernier scale coincides with 4 divisions of the main scale. So one vernier scale division will be how much? 4 by 5 of one main scale division. 4 by 5 of one main scale division. So when we calculate it, it will be how much? The least count will be 1 by 8 centimeter is 1.25 millimeter minus 4 by 5 into 1 main scale division is again 1.25 mm. So it will be how much? It will be 1.25 mm minus 1 mm. So it will be 0.25 mm. So this is the least count of vernier caliper. So we calculated the least count of vernier caliper. Now regarding screw gauge, what information we have? Regarding the screw gauge, we have information. The in screw gauge, we have information is the circular scale has 100 divisions. So the circular scale has 100 divisions, and one complete rotation of the circular scale moves by 2 divisions in the linear scale. So one rotation, it moves 2 division in main scale. So like in vernier caliper, there is main scale and vernier scale, and we calculated the least count of the vernier caliper. But in circular scale, it is only given that the circular scale has 100 divisions, and one rotation of circular scale, in one rotation of the circular scale, it moves 2 division in the main scale. So we don't have information regarding the main scale divisions, because but in case of vernier caliper, we had the information that 1 centimeter of the main scale is divided into 8 equal divisions. So how to proceed with the question? Now, since these two options are equal in their conditions, but the least count is different. So first we will assume that what will happen if the pitch of the screw gauge is twice of the least count of the vernier caliper. So it is given pitch of the screw gauge. So pitch of the screw gauge is twice of the least count of the vernier caliper. So then what is the least count of the vernier caliper we have calculated? So the least count of the vernier caliper is 0.25 mm. So pitch is how much? Pitch is 2 into 0.25 mm. So it will be 0.5 mm. So this 0.5 mm is the pitch of the screw gauge. Now we know the pitch of the screw gauge and the circular scale has 100 divisions. So what is the formula for calculating least count of the screw gauge? Can anyone tell me? So when we know the pitch and the number of divisions, so the least count of the screw gauge becomes pitch by number of circular scale divisions. Number of circular scale divisions. So the pitch is 0.5 mm and it has 100 divisions. So the least count of the screw gauge becomes 0.005 mm. So now as you can check in options A and B, so option B is true. So this is true because it says the least count of the screw gauge is 0.005 mm. And what is the condition? If the pitch of the screw gauge is twice that of the least count of vernier caliper. So we first calculated the least count of the vernier caliper, and then by taking the twice of the least count of the vernier caliper, we calculated pitch, and from pitch and the number of divisions on the circular scale, we calculated the least count of the screw gauge. So the least count of the screw gauge is how much? So this is the least count of the screw gauge. Least count of the screw gauge. So option B is correct. So option B is correct. Now we'll again consider the two options C and D. And in the option C and D, the condition is different. It says if the least count of the linear scale of the screw gauge is twice that of the least count of the vernier calipers, then the least count of the screw gauge is 0.01 mm. So here the condition is different, so the least count will be again be different. So the condition is if the least count of the linear scale, here we calculated a pitch and then we calculated the least count of the screw gauge, but in the option C and D, it is given if the least count of the linear scale is twice the least count of the vernier caliper, then least count of the screw gauge will be how much? So how will we proceed? So calculating the considering the second two options, suppose the least count of the linear scale of the screw gauge is twice the least count of the vernier caliper. So linear scale division will be how much? So for screw gauge, 1 linear scale division will be twice of the least count of the vernier caliper. So the least count of the vernier caliper, we know the least count of the vernier caliper is 0.25 mm. So it will be 0.25 mm. It is equal to 0.5 mm. Now this is one linear scale division. So again in question it says one complete rotation of circular scale moves it by two divisions on the linear scale. So the distance covered in the linear scale after one complete rotation of the circular scale is otherwise called as pitch. We know. So now we'll calculate the pitch of the screw gauge. So the pitch of the screw gauge will be how much? It will be 2 into circular. It will be 2 into linear scale divisions. So the pitch of the screw gauge will be 2 into linear scale division. It will be how much? 2 into one linear scale division is 0.5 mm. So it will be 1 mm. So now we again know the pitch. Then from pitch and number of division, we can calculate the least count. The least count of the screw gauge will be how much? Pitch by number of divisions in circular scale. So we know the pitch. The pitch is how much? The pitch is 1 mm and number of division is 100. So it will be 0.01 mm. So if you check the two options C and D, one says the least count is 0.01 mm and another option says 0.005 mm. So the correct option is C. So the correct options are B and C. So here what we found, it is 0.1 mm and it is the least count of the screw gauge. So option C is correct. So option B and C are correct options. Let me explain it once again. So in the question it was given that one vernier caliper has markings on the main scale and it is 1 centimeter on the main scale is divided into 8 equal divisions. So from this information we can calculate one main scale division. So one main scale division will be 1 by 8 centimeter, which is 1.25 mm. And again, the 5 divisions of the vernier scale coincides with 4 divisions on the main scale. So the one vernier scale division will be how much? 4 by 5 of main scale division. Since main scale division is 1.5 mm, so since main scale division is 1.25 mm, so it will be 4 by 5 into 1.25 mm. So the least count of the vernier caliper is 0.25 mm. Now the information regarding screw gauge, what we have? We have that the circular scale has 100 divisions and on one complete rotation, the circular scale moves 2 divisions in the linear scale. So we don't know the linear scale, so we can't calculate the pitch and we don't know the least count of the screw gauge. So in the options it is given some conditions related to the vernier caliper and using that condition we need to calculate the least count of the screw gauge. So the in the first two options the condition is same and in the second two options the condition is same. So any one option of the first two is true and any one of the second last option, the second two options are true. So when we consider the first two options, it is given the pitch of the screw gauge is twice that of the least count of the vernier caliper. We know the least count of the vernier caliper we calculated is 0.25 mm. So the pitch of the screw gauge will be twice of the least count. It will be 0.5 mm. And from pitch, since we know the number of circular scale divisions, we can calculate the least count of the screw gauge, and the least count of the screw gauge becomes 0.05 mm. That is 0.5 by 100 mm. So this is the least count of the screw gauge. And from the two options A and B, this says 0.01 mm. So the option B is true. Now, when we consider the last two options C and D, the conditions are different. The condition says if the least count of the linear scale is twice that of the least count of the vernier caliper. So here we calculated pitch directly, but here we will calculate the distance of each division in the linear scale. And since it is given on one complete rotation of the circular scale, it moves 2 divisions on the linear scale. Then we will calculate using that linear scale division, we will calculate pitch. So we know we have calculated first the least count of the slide caliper, which is 0.25 mm. Now one linear scale division of the linear scale of the screw gauge is 2 into 0.25 mm, which is 0.5 mm. So since it is in the question, it is given that on one complete rotation it moves 2 divisions. So we know the pitch is defined as the linear distance that the screw gauge travels on one complete rotation. So the pitch of the screw gauge becomes 2 into 0.5 mm, that is 1 mm. So from the pitch and number of division, again, if you calculate the least count, it will be 0.05 mm, that is 1 by 100 mm. So option C is correct. So from these from these four options, option B and C are both are correct, because here the condition is different, the least count is different. Yes. Anyone has any doubt?
Hello, sir.
Yes. Tell me.
Sir, I cannot able to see what you are displaying, sir.
Is it same for everyone? You can see my screen.
Yes, sir.
So who was saying he can't see my screen? Please tell again.
Sir, this is Ashish Rasto. Sir, I am not able to see.
So I request you to leave the meeting and join in the meeting again so that you can see the screen. Because
Okay,
I
sir.
have already shared the screen, and I think more all of the participants can see the screen.
Okay, sir.
So is there any doubt in the first question that we discussed today? So let's proceed to the next question of the day. And the question says, it is a very simple question. It says find the least count of the screw gauge whose head scale is divided into 200 division. If it moves 5, yes, if it moves 5 mm distance when the head scale is rotated to 5 revolutions. So we need to calculate the, please mute. Yes, someone has some doubt, I think. Yes, Jibananda, what's your problem? Yes, Jibananda, you have raised your hand. Do you have any doubt? So let's discuss the next question. And it says, find the least count of the screw gauge whose head scale is divided into 200 division. Here head scale means the circular scale. The circular head is written here as head scale, and it is divided into 200 divisions, and it moves 5 mm distance when the head is rotated through 5 revolutions. So we know the divisions. So can anyone tell me what is the formula to calculate the least count of the screw gauge? We know the least count of the screw gauge is given by pitch divided by,
Pitch by number of circular scale.
yes, number of circular scale divisions. So it is given the number of circular division is how much? 200. Now what will be the pitch? pitch will be the distance covered in the linear scale by total number of revolutions, because here it is given it covers 5 mm distance when the scale is rotated through 5 revolutions. So 5 mm distance divided by 5 revolutions, so it will be 1 mm. So the pitch here is 1 mm. So it will be 1 by 200. So what will be the least count of the screw gauge? Please calculate and tell me what will be the least count of the screw gauge, because as you can see the options are in centimeter and meter. So first you need to convert the answer to centimeter or meter and then tell me which will be the correct answer.
Option B, sir.
Option D.
B. 5 into 10 power minus 3 centimeter.
5 into 10 to the minus 3 centimeter. I don't think so. 1 by 200 is how much? It is 0.005 mm, is not it? It is 0.005 mm. So it will be how much? It will be 5 into, since it is 0.005 mm, so it will be how much? 0.0005 centimeter. So it will be 5 into 10 to the power minus 4 centimeter. Is not it? I request you to calculate once again. Did you get it right? Ashish Srivastav, please mute yourself.
Okay, sir.
I request everyone to mute themselves. Only when you want to ask something or you have any doubt, or I am asking something to you like, is I am audible, is my presentation visible, then you can unmute and answer me. So I request all of you to mute themselves. And in case you have any doubt, you can ask me. So the correct answer is 5 into 10 to the power minus 4 centimeter. So this is the correct answer, 5 into 10 to the power minus 4 centimeter. So the correct option is A. This one is the correct answer. Option A is the correct answer. Because it is a straightforward question. In the question it is given the least count of the screw gauge we want to calculate, and the head scale, that is the circular scale, has 200 divisions and it moves 5 mm distance on 5 revolutions. So since it is moving 5 mm distance in 5 revolutions, so pitch will be 5 by 5, so it will be 1 mm. And since it has 200 divisions, so pitch divided by number of circular scale divisions, it will give us, so pitch divided by number of circular scale divisions, it will give us 1 by 200. So it is 0.005 mm. Since the options are given in centimeter and meter, so we will be converting it to in centimeter. So when we know 1 centimeter is 0.1, 1 centimeter is 10 mm, or 1 mm is 0.1 centimeter. So when we multiply 0.1 here, it will be 0.005 centimeter. So in centimeter, it is 5 into 10 to the power minus 4 centimeter. So is there any doubt regarding this question? So let's proceed to the next question of the day. And the question says, the length is measured using a vernier system whose main scale is 30 centimeter long and is with 600 divisions. If 19 divisions of the main scale coincides with 20 divisions of the vernier scale, then what is the least count? So it is a very familiar question. We have solved similar questions in previous sessions also, and also in today's session, the first question was more or less similar like this. So I will give you a few minutes to try this and tell me what will be the least count of the Vernier system. So please note that here in the Vernier system, the main scale is 30 centimeter and it has 16 divisions, and 19 divisions of the main scale. 19 divisions of the main scale coincide with 20 divisions of the Vernier scale. So these are the informations you have, and please then using those informations calculate least count. In the last class, I think someone was asking me about the presentation slides that we are discussing the problems in this session. So if you go to the chat of the meeting, then in the chat section, I have shared the Google Drive link of the folder in which I am uploading the presentation slides. So you can click on the link and go to that Google Drive folder, and I have uploaded the previous session slides in PDF format. And after every session, I will be uploading the slides within 1 or 2 days. So you will be getting all the slides there only. So I think we'll be. Uh, it, so can anyone tell me what will be the answer in this question? Anyone solved it? Yes. Anyone? Solve it. Now we know what is the least count of the Vernier caliper. Can anyone tell me? Can anyone tell me?
Main scale division minus Vernier scale division.
Yes. So 1 main scale division minus 1
Minus
Vernier
Vernier
scale
scale.
division. So we can also say that so we can also to understand we can also say that we know Vernier caliper has 2 scales. So 1 main scale and 1 Vernier scale division. So when we want to calculate the least count, that is, what do you mean by least count of an instrument? The least count of an instrument is the minimum distance it can measure. So since it has 2 scales, each scale has some divisions. Like when we are considering a meter scale, it has divisions. In some scales, it has lowest division is of 0.1 centimeter or 1 mm. And or in some scales, there are more precise markings and they are 0.5 mm. But here, in case of a Vernier caliper, it consists of 2 scales. So one main scale and another Vernier scale. So since main scale has some divisions and Vernier scale has some divisions, so the least division we can found by subtracting the 2 scale divisions. Like when we are considering 1 scale division and when we compare it with the Vernier scale division, then we can find the difference on the 2 divisions, and from that difference we can find out the least count. Like we have 2 scales. These 2 scales are sliding one on another. So since each scale has some divisions, so when we try to calculate the difference between each division of each scale, then we will eventually find out the least count. So this is the basic principle. If you want to understand, like when you are considering a Vernier caliper, it has 1 main scale and there is another vernier scale. So this is main scale and this is vernier scale. So main scale has some division. So this is main scale division. Suppose this is the main scale division. I have drawn it on red, like so. Let me change the color. So suppose this is the vernier scale division. So vernier scale division, this is the vernier scale division. So blues are the vernier scale divisions and this is the reds are the main scale division. So when we slide the two scales on one on another, so the least, since we have two scales, so when we try to calculate the difference between each division of each scale, like in main scale, this is the difference. In main scale, this is the difference, and in circle in vernier scale, this is the difference. So when we slide upon, so when we slide the vernier scale on the main scale, so as it slides, we can distinguish the divisions of the main scale and vernier scale. So when we are calculating the least measurable distance, so it will be found out by subtracting one main scale division with one vernier scale division. So now come to our question. So in the question it is given the main scale is divided into 600 divisions and it is 30 centimeters. So one main scale division will be how much? One main scale division, how to calculate? 30 centimeter has 600 divisions. So one division will be how much? 30 by 600. So it will be how much? 30 by 600 is 1 by 20 centimeter, or it is 0.05 centimeter. So one main scale division is 0.05 centimeter. So since one main scale division is 0.05 centimeter, one vernier scale division will be how much? It will be, it is given 19 division of the main scale coincides with 20 divisions. So one vernier scale division will be 19 by 20 of one main scale division. So it is 19 by 20 into 0.05 centimeter. So when we find the difference, it will be how much? It will be 1 minus 19 by 20 into 0.05 centimeter. So it will be 1 by 20 into 0.05 centimeter, is not it? So it will be how much? It will be, least count will be 1 by 20 into 0.05 centimeter. So it will be 0.05 by 20, which will be how much eventually? 0.0025 centimeter. So it will be 25 into 10 to the power minus 4 centimeter. So if we check the options, the option D is correct, which says it is 0.05, it is 0.0025 centimeter. So option D is correct. So what we did here, in the question it is given the vernier scale has two scales. So in main scale, 30 centimeter is divided into 600 divisions, and for vernier scale, 20 divisions of the vernier scale coincides with 19 divisions of the main scale. So the least count is how much? We know the least count is one main scale division minus one vernier scale division. So since 30 centimeter is divided into 600 divisions, so one division will be 0.05 centimeter. So the 0.05 centimeter is the division of the main scale. Then considering the vernier scale, 19 divisions of the main scale coincide with 20 divisions. So one vernier scale division will be 19 by 20 into one main scale. So it will be, so when we calculate the difference, it will be 1 by 20 into 0.05 centimeter. So the least count will be how much? The least count is 0.0025 centimeter. So this is the least count. This is the correct answer. So option D will be correct. Is there any doubt in this question? Anyone? Yes. Yes, tell me. Okay, Sandhya, I'm requesting once again, please mute yourselves. It is creating irrelevant disturbances in the interact session. Then if you don't stop doing that, then I will be forced to leave you from the meeting.
Hello,
Yes.
sir. I have one doubt about the class.
Yes.
Sir, actually, I want all the PDFs these classes. So where we find?
So I was just saying. So okay, everyone go to the chat box of this. So in the topmost menu, you can see one chat is written. Can you find it? So when you go to the chat box, in the chat box, I have shared the link of the folder in which I will be uploading the PDFs. So did you find it? Kalpana, did you find it?
No, sir. I'm searching. Wait.
No, there is a menu called chat in the topmost bar in the Teams, and there you can find the folder link that I have shared today. For your confidence, I am sharing it once again. So once again, I have shared the link. Can you see it? Yes, can you see it? So let's discuss next question. And in case you are unable to find it, so I think you all must be knowing there is a discussion forum in the course in which you are registered. So in that discussion forum, I'll be pasting the link. So when you go to the discussion session of this course, experimental physics, you can easily find the link.
Okay, sir. Okay, thank you.
Okay. So let's discuss the next question of the day. Now the question says, in the given screw gauge, the zero of the main scale coincides with the given screw gauge. The zero of the main scale coincides with fifth division of the circular scale, and the circular scale has 50 divisions, and it moves 0.5 mm on the main scale in one rotation. So find the diameter of the ball as shown in the figure below. So as you can see, there are two figures here. One is without any object that we want to measure, and one is with an. So here we have nothing to measure. Here, as you can see, we have nothing to measure, but here there is a ball placed here. So when we have nothing to measure and we connect both the linear scale with this, we find the zero error. And in this question, it is given the zero of the main scale coincides with fifth division of the circular scale. So the zero of the main scale coincides with fifth division of the circular scale, and the circular scale has 50 divisions, and it moves 0.5 mm on the main scale in one rotation. So these are the informations given in this question, and it is given that find the diameter of the ball as shown in figure. So with this information, you can easily find the diameter of the ball. So I will be giving you a few minutes to try this question, and then we'll discuss. Anyone solve the question? Can you answer the question? What will be the diameter of the ball as shown in the figure? Anyone? I think it is answerable when you consider the questions we have solved. It will be very similar to all these questions that we have already solved. So you should not find any difficulty in solving this question. So anyone calculated the answer? Yes. Anyone?
2.007 millimeter.
Sorry, 2.007
millimeter.
No, it will be the answer will be 2.20 millimeter. I request you to check the calculations. Please keep in mind that there is a zero error in the question. As you can see here, it is given when the main scale coincide, when the two ends are joined here without any object, the zero of the circular scale coincides with 5 of the main scale. The zero of the main scale coincides with 5 division of the circular scale. So what you need to do, I'm explaining it again. What you need to do, first you need to calculate the least count, and from that least count, once you calculate the least count, you will be able to calculate the zero error, because since it is given 5, the zero error will be 5 into the least count. And when you apply the steps of measurement with this ball, so we'll be calculating the length that will be measured through the screw gauge. And after that, since the zero error is positive here, because here it is 5 divisions, so 5 is greater than 0. But when it was, but when in some case there can be negative zero error, and in that case, this 0 coincides with 45 or 47 like that. So then there will be negative zero error. So since negative zero error is added and positive zero error is subtracted, because negative zero error has additional negative sign. So when we subtract the error, it will be added. But here, since it is a positive zero error, it will be subtracted from the actual reading. So with this setup, in the second, when the ball is placed between the two hands, you can easily calculate the measured size of the ball or diameter of the ball, and from that measured value, when you subtract the error, then you can find the actual diameter of the ball. So please try it once again. I'll giving 1 minute more, and if you are able to calculate it, it's okay. Then again, I will be explaining it. So I request everyone, so please try to participate in the discussions. It will be better for you also, because the main aim of this interaction session is to clarify your doubts, and it will also help you to solve the assignments. So if you have any doubts regarding the discussion session, or if you have any suggestions how we can improve the interaction session, it will be really welcome. So let's calculate the actual diameter of the ball as shown in the figure. So in the question, it is given 0 of the main scale coincide with 5th division. This is given as 5th division. 0 of the main scale coincides with 5th division, and the circular scale has 50 divisions, and it moves 0.5 mm in one rotation. So we know first we need to calculate the least count of the screw gauge. So it will be a least count. What is the formula of the least count? Pitch divided by number of division in circular scale. So what will the pitch? It is given, it moves 0.1 mm on the main scale in one rotation. So the pitch will be 0.5 mm. So it is 0.5 because it is given 0.5 mm it moves in one rotation. And the number of division in the circular scale has 50 divisions. So the circular scale has 50 divisions. So it will be 0.001 mm. So it will be 0.01 mm or 0.001 centimeter. So least count is 0.001 centimeter. So when you calculate the zero error will be how much? It is given the 0 of the main scale coincides with 5th division. So 0 error will be 5 into least count. It will be 5 into 0.001 centimeter. It is 0.005 centimeter. So the zero error is 0.005 centimeter. So now we'll find the reading in the second. As you can see, in the main scale, one division is 1 mm. So it is 0.2 mm. So as you can see, the main scale, this is 1, 2. So the main scale reading is 0.2 mm. And after that 0.2 mm, this line coincides with 25th division of the circular scale. So we know in case of screw gauge, the measurement is given by the measurement is main scale reading or linear scale reading plus circular scale reading. So the linear scale is 0.2 mm plus this line coincides with 25 divisions of the circular scale. So it will be 25 into least count. So it will be 0.2 mm plus 5 into 0.00. It was 0.01 mm, so it will be 25 into 0.01 mm. It will be 0.2 mm plus 0.25 mm. Sorry, this is not 0.2 mm, this is 0.2 centimeter. So this will be 2 mm. So the linear scale will be, it will be linear scale reading. The circular scale reading, linear scale is 2 mm or 0.2 centimeter. So it will be 0.2 centimeter minus 25 into, since we are writing it in centimeter, so we need to write the least count also in centimeter. So least count in this case is how much? In this case, the least count is 0.001 mm, 0.001 centimeter. Sorry. So again, so this is 0.2 centimeter plus 0.025 centimeter. So it is 0.225 centimeter. So this is the measurement, but the actual diameter will be how much? The actual diameter will be how much? Measured value minus the zero error. Since the zero error has positive, we will directly subtract. So it will be 0.225 centimeter minus, this is 0.005 centimeter. So 0.005 centimeter. So it will be 0.220 centimeter, or when we write it in millimeter, it will be 2.20 millimeter. So this is the correct answer. 0.002 millimeter, 0.002 centimeter, 0.220 centimeter, or 2.20 millimeter. So let me explain it again. Now in the question it is given the zero of the main scale coincides with fifth division of the circular scale when there is no object. So it has some zero error. And in the second case, there is a ball placed in the screw gauge and this is the reading. And it is given the circular scale has 50 divisions and it moves 0.5 mm on one complete rotation. So the distance moved on one complete rotation known as pitch. So the pitch is 0.5 mm, and using the pitch and number of divisions in the circular scale, we can calculate the least count of the screw gauge. So the least count of the screw gauge is 0.5 by 50. So it is 0.01 mm or 0.001 centimeter. So since the least count is 0.001 centimeter, the zero error will be 5 into least count because the zero of the main scale coincides with fifth division. So these 5 divisions is of error. So the least count into 5 will be the amount of error that we found in the measurement device. So the zero error will be 0.005 centimeter. So when you see here in the measurement, we are seeing there is 1 and 2. So it is 1 mm. So the linear scale is this is 1 mm, this is 2 mm. So it is 2 mm or 0.2 centimeter. So the linear scale reading is 0.2 centimeter and the circular scale reading is here. It is you can see this coincides with 25. So it is 25 into least count. So 25 into least count is 0.025 centimeter. So linear scale reading plus circular scale reading, it is the total reading. The total reading is 0.225 centimeter. But since the measurement device has some zero error, so we will be subtracting that zero error to get the actual value. So the actual measured diameter will be 0.225 minus zero error, that is 0.005, and this is 0.220 centimeter. Or in terms of millimeter, it will be 2.20 millimeter. So is there any doubt in this question? Yes. So let's discuss one new measurement device. So now this we know this is the moving coil galvanometer. So it contains, since its name suggests, it contains a coil and which moves. How will it move? To move the coil, it is placed in the magnetic field. So as you can see, this is the diagram of a mechanism through which a moving coil galvanometer works. So basically, it has a coil. This is the coil. And this is the iron core or something upon which the coil is wounded. And the coil is in the second part. It is connected to a spring. And the coil is placed in between two pole pieces of the magnet. That is, the coil is placed inside a magnetic field. So as you can see, when we know and the current is passed through this coil, and we know when a current carrying conductor is placed inside a magnetic field, it experiences some force. So the coil will be experiencing some force. So if this is the coil, so this is the magnetic field, and within this magnetic field, we are placing a coil. So this will be the coil. So suppose this is the magnetic field in this direction. So the current is passing through the coil. So this is like that. Here it is a spring. So this I have shown you only a single turn, but there are a many number of turns. So current will pass in this direction. Suppose current is passing this, then it will travel like this, then it will go this. So if this is the B vector, so it is in this direction. Suppose in this, for this case, B vector is in this direction. This is B vector and current is in this direction, I. So according to the principle, when a current carrying conductor is placed inside a magnetic field, it will experience some force, and that force is given by F is equal to B cross I dl vector. So here in this case, since B is in this direction and this current is in downward direction, so B cross I will be how much? B cross I will be in which direction? It will be. So when you apply the right hand thumb rule, so B cross I will be downwards. So here in this case, the B cross I will be downwards to the plane of paper. But here in case when the current is flowing upwards, the magnetic field is in this direction. The current is in this direction. So when you check the direction of the force, it will be upward. So if you consider the coil is like that. When you see the coil in top side, like in this figure, so in one it will, the force is in downward direction, and in one end the force is in upward direction. So due to this force, the coil will rotate that is the coil will experience some torque. So when the coil is rotating, so the since as you can see, if the magnetic field is produced due to the two poles of the magnet which are plane, so when we rotate the coil, then the magnetic strength will change. But do you want to make a uniform rotation, so the magnetic field strength should be constant, because force the magnetic field for a particular constant force, the magnetic field should be constant. So in order to produce that constant magnetic field, the pole pieces are made like that. So in this case, so when the coil is rotating, so the magnetic lines of force are always perpendicular to the plane of the coil. So irrespective of its direction of rotation, the field strength remains same. So this is the reason for which we are using these circular pole pieces of the magnet. So due to this, due to this force, it will experience, due to this torque, it will experience some force. So now if we find out the torque will be how much? Force into perpendicular distance. So this torque produced due to the magnetic field will be, torque tau will be force into perpendicular distance. So now due to this torque, it will rotate, and in order, so since the spring is connected in the other end of the, then the spring is connected in the other end of the wire, then the spring will get twisted. And once the spring will get twisted, it will store some energy, and the again there will be, since it will want to come back to its original position, so the spring will again rotate in opposite direction. So what happens here? We know the torque produces force into perpendicular distance. Now if you calculate force will be how much? Bi into dl. So this is force into perpendicular distance. So this total will be the torque, and this torque is NIAB. So here A is the area of the, so here this A is the area of the coil. Area means length into breadth. So this force is I B into L, because it's IBDL. So this is IBL into perpendicular distance will be B. So that will be IBA. So when there are a number of turns N, it will be IBA into N. So this is the torque. And since the spring produces torque, so the spring constant is K, and theta is the deflection. Like here, as you can see, there is a mirror. There will be some deflection which we can see in the mirror. So the in the equilibrium case, in the steady state, in the steady angular deflection case, the two torques balance each other. So it will be K theta balanced by NIAB. So if you if you see this relation, you can see here K is the property of the spring, N is the number of turns of the coil which is constant, A is the area of the cross section of the coil, and B is the magnetic field. Magnetic field is constant in this case, so the only variable is I. So here this theta we can vary with varying the current. So this is the twist that is produced in the coil due to the force applied by the magnetic field, and that twist will be depending upon the current passing through the coil. So from this relation, that is theta direct proportional to I, we can calculate the current and voltage sensitivity of a galvanometer. So when you calculate the sensitivity of the galvanometer, since theta depends upon I, so the sensitivity is defined as the change in theta with respect to change in current. So since galvanometer, we know galvanometer can measure both voltage and current. So there are two sensitivities. One is voltage sensitivity, another is current sensitivity. So the current sensitivity is the deflection in theta per unit current passing through the coil. So if you see this relation, from this relation we can easily find this condition, that is theta by I is equal to NAB by K. And if you calculate the voltage sensitivity, it will be similarly theta by V. We know V is equals to IR, so there will be an additional R in the denominator. So if you see the relation, the voltage sensitivity will be current sensitivity divided by resistance of the coil. So this is the overall principle of the moving coil galvanometer and the voltage and current sensitivity. So let's solve a few problems. So this question says a moving coil galvanometer has the following characteristics. A moving coil galvanometer has the following characteristics. It has number of turns of the coil is 50. Area of the coil is 70 millimeter square. Resistance of the coil is 30 ohm. Flux density of radial field, that is magnetic field intensity, is 0.1 Tesla. Torsional constant of the suspension wire, that is K, is 7 × 10⁻⁸ Newton meter per radian. So from these informations, we want to calculate the current and voltage sensitivity. So here it is given. The number of turns of the coil is 50. Area of the coil is given. Magnetic field is given. Resistance is given. The constant spring constant K is also given, and we want to calculate the current and voltage sensitivity. So in this formula, you can easily see this is the formula of current sensitivity, that is theta by I, and this is the formula of voltage sensitivity, theta by B. So once we calculate the current sensitivity, simply we can divide by the resistance of the coil 30 ohm is given here. We will able to calculate the voltage sensitivity. So I'll be giving you a few minutes to try this, then I will be solving it. So please try it and tell me what will be the correct option. So anyone solve the question? Solve this question. It's a very straightforward question. You have the formula for current sensitivity. You simply need to put the values here. So we know the current sensitivity is given by, suppose this is the current sensitivity Is, it will be theta by I. And it will be how much? It will be N A B by K. And in the question, N is given, N is 50 tons. A is area of cross section of the coil, which is 70 into 70 millimeter square. And when you convert millimeter into millimeter into meter, it will be how much? It will be 17 10 to the power minus 6 meter square. And B is 0.1 Tesla. And one more information is given, which is K. K is the torsional constant of the suspension wire, which is 7 into 10 to the power minus 8 Newton into meter per radian. So when you put all this, so what will be the, it will be 50 into A is 70 into 10 to the power minus 6 into 0.1 divided by K is 7 into 10 to the power minus 8. So can anyone calculate it and tell me what will be the current sensitivity? Yes, please calculate and tell me what will be the value of the current sensitivity.
Sir, 5,000.
5,000 unit. Because as you can see here, it is given all in division per milliampere, division per millivolt. So
Milliampere.
I think it will be 5 division per milliampere. It will not be 5,000. Because 5,000 when you convert into milli, since it is, since milliampere is in denominator, so it will be 5,000 by divided by 1,000. So it will be 5 divisions per milliampere. It will be how much? 5 division per milliampere. So this is the current sensitivity. Suppose in the question it is given, in the answer, the options are given in terms of ampere. So when you convert it into ampere, we know 1 ampere is how much? 1,000 milliampere. So since it is in milliampere, so we need to convert it into ampere. So 1 milliampere will be how much? 1 by 1,000 ampere. Since the milliampere here is in denominator, so 1 by 1 milliampere will be how much? 1,000 1 by ampere. So here it will be 5,000 division by ampere. So now you can see when it is in milliampere, it is 5 division per milliampere, but when it is in ampere, it will be 5,000 division per ampere. So similarly, this is the current sensitivity. So when we calculate the voltage sensitivity, we know voltage sensitivity is current sensitivity by resistance. The current sensitivity is 5 division per milliampere. So when we divide it by resistance, resistance is how much? 30 ohm. So resistance is 30 ohm. So since it is milliampere, it is ohm. So it will be millivolt. So it will be 5 by 30, that is 0.167 division per millivolt. 0.167 division for millivolt, or in volt it will be how much? It will be 167 division per volt. So the correct option is option C, that is 5 division per milliampere and 0.167 division per millivolt. So this is the question. In this question, it was given the number of turns of the coil is 50, area of cross section of the coil is 70 millimeter square, resistance is 30 ohm, and the flux density is 0.1 Tesla. So the torsional, and again the torsional constant K is given 7 × 10⁻⁸ Newton meter per radian. So when we are calculating the current and voltage sensitivity, we know the formula is current sensitivity is given by theta by I, so it is NAB by K. So when you calculate, it will be 5 division per milliampere. So again, we know the voltage sensitivity is given by current sensitivity divided by resistance of the wire. So the resistance of the wire is 30 ohm. So 5 by 30 is 0.167 division per mill. So 0.167 division per millivolt. So the voltage sensitivity is 0.167 and the current sensitivity is 5. So the correct option is option C. Is there any doubt in this question? Anyone? Okay, so generally the galvanometer is used to measure small currents. So in case of measuring high current and high voltage, we can convert the galvanometer into ammeter or voltmeter. We know ammeter is used to measure current and voltmeter is used to measure voltage. So how we can convert galvanometer into voltmeter or ammeter? We know ammeter is a very low resistance galvanometer and voltmeter is a very high resistance galvanometer. So how we can convert the galvanometer to very low resistance? So when we convert a very low resistance, so we need to do something so that the resistance of the galvanometer will be decreased. So how we can decrease the resistance of the galvanometer? We know when we suppose there is a resistance R, we need to modify the circuit so that the equivalent resistance will be less than R. So what we can do? So in this case, when we connect a small resistance in parallel to the resistance R, then it will convert the equivalent resistance of the system to lower value. So in order to convert ammeter into a, in order to convert galvanometer to ammeter, we connect a small resistance in parallel to the galvanometer, which is called as shunt. So as you can see here, when we calculate, suppose this is the current I is flowing, since this is the galvanometer G, it has some resistance. Suppose the resistance of the galvanometer is G and the resistance which is connected in parallel to the galvanometer is S, that is shunt. And the current passing through the galvanometer is IG. So since current I is passing here, IG flows through the galvanometer and the remaining current, that is I minus IG, flows through the resistance S. So we know when we are seeing two parallel branches, this is one branch which has only galvanometer and another branch which has only resistance S. So in both the branches, the voltage remains same. So when you calculate the voltage will be how much? Voltage will be V is equals to IR. V is equals to I into R. So it will be IG into G, which is equals to I minus IG into S. So this is the working formula, and from this, using this formula, we can calculate, if we want to calculate some value of the current, then what should be the shunt resistance that we want to connect in this case. Similarly, in case of the voltmeter, as you can see, this is the overall resistance of the circuit, and I said that the resistance of the ammeter is low. So when the resist, suppose there is a circuit and we want to measure the current. So current and resistance relation is I right proportional to V, and V is equals to IR. This is the relation. So when the resistance value changes drastically, the current will also change. That's why, since it has low resistance, so when the low resistance is connected in series, the resistance is added. So as the resistance is low, so it will not affect the overall resistance of the circuit, and that's why the ammeter is connected in series. Because when the ammeter is connected in series, the total resistance of the system remains unaffected and we can accurately measure the reading, that is the current or the voltage. Similarly, in case of the voltmeter, voltmeter is a high resistance galvanometer, and in order to convert resistance to in order to convert a circuit to a high resistance, simply we can connect a high resistance in series, because we know when both are in series, it will be simple R1 plus R2. So when this R2 is high, the total resistance, equivalent resistance will be high. And since this equivalent resistance is high, when we want to measure the voltage passing through a circuit, we need that the measurement should be measurement should be accurate, and it should not be affected by the system of the resistance of the voltmeter. So in this case, only when we are connecting it in parallel, it will not affect, because when we connect small resistance in series, it will not affect the equivalence resistance, and when we connect high resistance in parallel, it will not affect the equivalent resistance. Because let's suppose, let me add another. Let's understand this in terms of an example. So suppose there is a circuit, there is a resistance R. R is 100 ohm, and with this resistance we connected a small resistance. The small resistance is 0.1 ohm, and the large resistance, suppose the large resistance is G. It is how much? It is 10 kilo ohm. So in one case, this is R. Suppose we want to do a circuit in which we want to try that this R should remain unaffected or it should not change, which is 100 ohm. So we have two things. This is S, which is 0.1 ohm, and it is G, which is 10 kilo ohm. So when we are connecting this 10 kilo ohm in series, suppose we are connecting this 10 kilo ohm in series. So if this is 10 kilo ohm, then the overall resistance will be how much? This will be 10 kilo ohm plus 0.1 kilo ohm, so it will be 10.1 kilo ohm. So you can see this is 0.1 kilo ohm, this is 10.1 kilo ohm, and it varies drastically. So it should not be the way. So when you want to minimize the effect of the additional component, then if it is of high resistance, we can connect it in parallel. So what we will do, we will connect this is R, we will connect this G in parallel. So when we are calculating the equivalent resistance, it will be, the formula is 1 by R plus 1 by G. So 1 by R is 1 by 100 plus 1 by 10k. 10 kilo ohm means 10. It will be 1 by 100 is how much? 0.01. 1 minute. So it will be 1 by R equivalent is how much? LCM is 10,000. So 100 is how much? 100. So it is 100 plus 1. It is 101 by how much? 101 by 10. 10,000. So R equivalent will be how much? R equivalent will be 10,000 divided by 101. What is the value of 10,000 divided by 101? It is coming around 99 point something. So it is 99 point, how much? 99.009 ohm. So you can clearly see when there is a very large resistance and it is connected in parallel, then the equivalent resistance remains same. So the equivalent resistance does not change much because the initial resistance was 100 ohm, and when we connected the large resistance in parallel, the equivalent resistance becoming 99. So only 1 ohm is change. So only 1 ohm is the difference is only 1 ohm, and we know the voltmeter is a high resistance galvanometer. So since the voltmeter has high resistance, in order to in order to have minimum effect on the resistance, the voltmeter is always connected in parallel of the circuit. Similarly, if you have any small resistance, it is simple. Since the resistance is small, we can easily connect it in series, and so that the total resistance will not change, because 100 plus 0.1 is 100.1. It is not increasing much. So since ammeter is a low resistance galvanometer, it is connected in series. So the voltmeter connected in parallel with the circuit, but in voltmeter, a high resistance is connected in series with the galvanometer. And in case of ammeter, ammeter is a low resistance galvanometer, and in case of this ammeter, a very small resistance is connected in parallel with the galvanometer, and ammeter is always connected in series in the circuit to measure current, and voltmeter is always connected in parallel to measure the voltage. So this is the basic principle on which ammeter and voltmeter works. So is there any doubt in this portion of the explanation? I think it is quite important if you know how we can convert the ammeter into voltmeter. Yes, is there any doubt? Let's solve a few questions related to the voltmeter and ammeter. So now the question says, what is the value of the shunt resistance S? What is the value of the shunt resistance S, which is required if a galvanometer has a resistance of 50 ohm and a maximum of 0.05 ampere current can be passed through it? The ammeter range is changed to 20 ampere. So the total current that passing through the ammeter setup is 20 ampere, and what resistance we want to connect in parallel with the galvanometer, so that the 0.05 ampere of current will be passing through the ammeter only. So this is the question. These are the options. Please try the question and tell me what will be the value of the resistance. You can use this formula. This is the relation. This is the ammeter setup, and this is the formula. If current I is passing in this question, I is given, Ig is given, G is given. We want to calculate S. This is the formula. So try to calculate and tell me what will be the resistance we want to connect, so that the ammeter range is 20 ampere and only 0.05 ampere current will be passing through the ammeter. Only will be passing through the galvanometer. Did anyone calculate? So let's solve this question, and it is given here. Galvanometer has resistance of 50 ohm and the maximum current passing through the galvanometer 0.05 ampere and the range is 20 ampere. So when you draw the circuit of the ammeter, then this is the galvanometer. This is the galvanometer G, and we need to connect the resistance S in parallel to convert it to ammeter. So this is the shunt resistance S. So in this case, this is the current I, total current. So Ig is passing through the galvanometer and I minus Ig is passing through the shunt resistance. Again, it will be adding up here and the total current again will be I. So this is according to Kirchhoff's law, simple. So we want to calculate what will be the shunt resistance S. So when you apply simple Kirchhoff's law here, voltage in both the branches are same because these branches are parallel. So the voltage will be Ig into G, which will be equal to I minus Ig into S. That is, here we want to calculate S. So S will be Ig by I minus Ig into G equal to S. So in question it is given total current I, that is the ammeter range, which is 20 ampere. The current passing through the galvanometer is 0.05 ampere. And the resistance of the galvanometer, that is G, is 50 ohm. So putting all these values, can anyone tell me what will be the value of S? So you can see in this question, the ammeter range is 20 ampere, but only small amount of current is passing through galvanometer. Because since the resistance of the, since if you compare the options are in decimal points, but the resistance of the galvanometer is 50 ohm. So when you compare the two resistance, the resistance of the shunt is very low. So most of the current passes to the shunt. So the use of shunt in case of a ammeter is to bypass most of the current so that only small current passes to the galvanometer. Because we know galvanometer is used to measure very small currents, that is small deflections it will be producing. So when you put all these values, the shunt resistance will be how much? S will be Ig is 0.05 into G is 50 divided by 20 minus 0.05. So this is 2.5 divided by 19.95. This is 0.125 ohm. So this is the correct answer. And when we, so this option B is correct, 0.125 ohm. And when we connect this 0.125 ohm in parallel with the galvanometer, then it can measure up to 20 ampere and only 0.05 ampere of current will be passing through the galvanometer. So most of the current will be bypassed through the shunt resistance because it is very small. Is there any doubt in this question? Anyone? Yes? Any doubt? Okay, so we can go to the next question. The question says the current passing through a galvanometer is 30 milliampere. The resistance of the galvanometer is 50 ohm and a shunt of 1 ohm is connected to the galvanometer. What is the maximum current that can be measured by this ammeter? So this is very similar to the previous question, but here we want to calculate capital I. That is, so this is the equation. Similarly, when you apply the same relation, it will be Ig into G is equals to I minus Ig into S. So Ig into G equal to Is minus Ig into S. So Is is equals to Igg plus Igs. So I will be G plus S into Ig divided by S. So this is the relation. And in the question, we have everything. G is 50 ohm, S is 1 ohm, and Ig is 30 milliampere. So please put all these values. So I am writing it once again. I is G plus S divided by S into Ig, where Ig is 30 into milliampere 10 to the power minus 3 ampere. G is 50 ohm, S is 1 ohm. So please put all these values and calculate what will be the range of this ammeter. Anyone? Please calculate and tell me what will be the range of this ammeter. Yes. So when you calculate it, it will be how much? It will be 50 plus 1. 50 plus 1 by 1 into 0.03, because 30 into 10 to the minus 3, 0.03. So it will be 51 into 0.03. It will give us 1.53 ampere. So the range of the ammeter is 1.53 ampere. It is 1.53 ampere. This is the correct answer. So as you can see here in the question, the shunt resistance was how much? Here, if you see simply, it was 0.05 ampere or 50 milliampere. The 50 milliampere current was passing through galvanometer, and the shunt resistance was 0.125 ohm, and the range was 20 ampere. But here, the shunt resistance is 1 ohm, and the range is reducing to 1.53 ampere. So when you use shunts of very low resistance, you can measure more current or the range can be varied. So you must, anyone know about multimeter? It is an instrument which is popularly used in the lab to measure current, voltage, resistance, capacitance, everything. Anybody know about multimeter? So basically in multimeter, when you I will try to show you say a multimeter in the next class. So basically in a multimeter, what happens? In a multimeter, you can change the range. Suppose you are measuring current, you can change the maximum current. That is, whether you want to set the range 3 ampere, 3 milliampere, 10 milliampere, 30 milliampere, 1 ampere, like that. So this is the principle. So when we change the knob of the multimeter, the circuit is like that. The shunt resistance is changed. So according to this shunt resistance, so according to this change in shunt resistance, we find the new range. So if you compare the two questions, smaller is the shunt resistance connected in parallel with the galvanometer, larger will be the range of the ammeter which is used to measure a current. Is that clear to all of you? So we can say that here we can say that shunt larger the range of the ammeter. So if the value of the shunt will be decreasing, so the maximum current range will increase. So this is the two questions which will help you to identify this principle, like how to change the range of a ammeter. So I think we should stop here, and in the next session we'll be discussing about the electrical components like resistors, capacitors, inductors, and we'll be solving a few problems. Also, we'll try to cover the cathode ray oscilloscope, which is used to see the waveforms. And so, is there any doubt? Anyone?
No, sir. No, sir.
So, please go through all these questions that we have solved. So it might help you in. I think the submission of assignment date is over. If you have any doubt in the solution of the assignments like assignment 1 and assignment 2, you can ask me. And these kind of questions will really help you in appearing in the exams that will be appearing in the end of this course. So I wish you all the best. Thank you. So we should stop the meeting now. Yes, is there any question, or I should end the meeting? Okay. Bye bye. Good night all.